Let's start to the Vogel's approximation method. This is the third method for transportation problem solving. We already gone through the least cost method and northwest corner rule. So our data are given, that is our plant and destination. The question is like that: the plant is A, B and C. Our data, our destinations are D1, D2 and D3. Sources are given and demand is also given. The cost matrix, unit cost matrix is given. The values are like that. From A to D1, the unit cost is 6, A to D2 unit cost is 8, A to D3 unit cost is 10, B to D1 unit cost is 7, B to D2 unit cost is 11, B to D3 unit cost is 11, C to D1 4, C to D2 5 and C to D3 the unit cost is 12. So our sources are 150, total source cost are 150, 175, total product are 275, and for the demand, our demand values, the demand products are 200, 100 and 300. So in doing this, firstly we have to calculate the sources, summation of sources. Our sources are 150, 175, 275. So the values are 150 plus 175 plus 275, total becomes 600. And the summation of demand are 200 plus 100 plus 300, so total 600. Since our sources are equal to demand, so we can say that it is a balanced transportation problem. So we can solve this problem using the conventional method. So in doing such, firstly we have to calculate the penalties. So in calculating the penalties, firstly take the value 6, 8, 10 and total sources are 150, 7, 11, 11. The total source product are 175, 4, 5, 12, 275. The demand are 200, 100 and 300. And within the cost matrix, we can see that in the row, firstly consider row wise to calculate the penalties. Penalties. So in calculating the penalties, say within 6, 8, 10, the lowest value are 6 and 8. So the difference between 6 and 8 is 2. Within 7, 11, 11, lowest values are 7 and 11. So within that, the lowest two are 7 and 11, difference is 4. Within 4 and 5, 4, 5 and 12, the lowest values are 4 and 5, the difference is 1. And now consider column wise. Within 6, 7, 4, the lowest values are 6 and 4, so the difference between twos are here also penalties. We are calculating the penalties. Within 6 and 4, the difference is 2. 8, 11, 5, the lowest values are 8 and 5, so the penalties are 3. 10, 11, 12, the lowest values are 10 and 11, so the differences are 1. Now we have to choose the highest penalty. Here our highest penalty is 4, and we have to choose this column, actually this row, and we have to choose this row, and within this row our lowest value, the values are 175. So we have to assign 175 in the lowest unit cost. We have to assign 175 here. So this row become exhausted, so it becomes 175 minus 175 0, and within 175 it is assigned already 175, so 200 minus 175 it becomes 25. So now in the next step our matrix become 6, 8, 10 and 4, 5, 12, and within that our say our sources are 150 and 275, and in the demand the values are become 25, 100, 300. Now again we have to calculate the penalties in the column wise and row wise, and also in the column wise. In the row wise, the lowest values are 6 and 8, so difference is 2. The lowest values are 4 and 5, difference is 1. Within 4 and 6 and 4, here is only 2 values, so these are the two lowest values. 8 and 5, lowest value is 3. 10 and 12, lowest value is 2. So within these our penalties, maximum penalties is 3. So we have to assign 100 to this column, to the lowest unit cost. Our lowest unit cost is 5, so we will assign 100 to the 5. So this column become exhausted, and corresponding this row become 275 minus 100 becomes 175. Now our matrix becomes 6, 10, 4, 12, and the matrix values are like this: 150, 175, 25, and 300. And now again we have to calculate the penalties in the column wise, row wise, and also in the column wise. It is 4. Now the values are 8. Now it is 2 in the column wise, and also 2. So maximum value is 8. So we have to assign 175 to the lowest unit cost, that is in the 4. So if we assign 175 in the lowest unit cost, if we assign here, if we assign the in the lowest unit, 100 is already assigned. Now we have to take 175. If we assign 175, to the A, to the lowest unit cost, here it is actually 25 is already exhausted, you cannot use this, so you have to assign 25 here. So within this there is actually challenge over here. We have to assign the 25 here, the lowest penalty. We have to consider in this case, since it is 175 and 25, the lowest is 25, so we have to assign 25 here. If we assign 25 here, then it is exhausted. In that case, corresponding 175 minus 25 becomes 150, and this, now the matrix will become 10, 12, 150, 150, and this one is 300. So obviously we can easily solve this. We have to assign 150 to 10 and another 150 to 12. That's it all about the least cost method, because within this, here is the trick, that is if we assign 175 here, it is actually 25, so it cannot exhaust it, so we have to assign 25 firstly in that case. In that case we have to assign 25. So if we assign 25, we can solve the other problem like this. So the total minimum cost, that is transportation cost, will be, if we watch it, follow it carefully, we have to assign 7 unit cost to 175, assign 5 unit cost to 100 product, 4 unit cost to 25 product, 10 unit cost to 150 product, 12 unit cost to 150 product. If we sum all this, 7 into 175, 5 into 100 plus 4 into 25 plus 10 into 150 plus 12 into 150, the value becomes 5,125, say it is in BDT. So that's it all about the program. So that's it all about our math. So in this method we can solve the transportation problem. Thank you so much for watching this video. hope you can see the full Vogel's approximation solution here. The only tricky part is that where we cannot assign at the end. In that case, we have to assign the minimum value here. Thank you so much.